Alright, so here's the last video, the question that we went over in class yesterday in the exam review. First one has to do with opportunity costs. Remember that you have three options. You can either do your laundry, you can also go to work, or you can actually go out with your friends. If you go out with your friends, what's the opportunity cost of this? Well, the opportunity cost will be the value of the best alternative. You cannot do the three things at the same time. You cannot even do two things at the same time. You cannot work and also do your laundry. So you're only going to give up one of those two things. If you did not have to go out drinking, which of these two things you would do? Well, you will do the one that you value the most. And since you're willing to pay $80 to someone else for doing your laundry, that's how much you value doing your laundry, so that's what you would do. So therefore, the opportunity cost of going out with your friends is $80. Another way of looking at this is saying, well, if you go out with your friend and you cannot do the laundry, how much will you be willing to pay to do your laundry? Well, it's $80. So therefore, going out with your friend is essentially costing you $80 because you cannot do the laundry yourself. You have to pay someone else for doing it. So that's another way of looking at it that would also work too. Now, see that in any case, in all of these situations, you are actually going to go to work. You're not even going to pay someone else to go to work because that actually doesn't make sense to you. You could actually pay someone else to do your laundry and you'll be much better off, or you can just do the laundry yourself. This one is a typical question about supply and demand. The input changes what happens to the equilibrium price of two substitutes. Chicken feed is the input in chickens. If the price of chicken feed goes down, the equilibrium price of chicken will probably go down because the supply increases, so that's a fall. Now that eliminates C and D. Now beef is a substitute. If the price of chicken goes down, people will buy more chicken and less beef, so the demand for beef goes down and the price for beef goes down. So the answer here is that both prices, equilibrium price, goes down, which is A. Another question similar to that is about the inputs and two things that are, in this case, substitute beef. Again, I'm not sure why I do so many questions with meat. I used to be vegetarian, so beef and pork are substitutes. If the cost of corn and input in the production of beef goes down, what happens to the price of beef and pork? In particular, what happens to the demand and supply of pork? Well, a decrease in the price of corn will actually increase the supply of beef. So therefore, A and B are wrong. And an increase in the supply of beef reduces the price of beef, and that decreases the demand for pork. Therefore, the answer here is C, increases the supply of beef and decreases the demand for pork. And here's finally a question in which two things happen at the same time. You can answer it with a graph or without the graph. The important thing is that you keep things organized and you evaluate each change one at a time. So let's do that here. The first thing that happens is that the demand for roses increases. As the demand for roses increases, what happens to the price and the quantity of carnations? The demand for roses increases. That is going to increase the price of roses. Therefore, it's going to make more people buy carnations. So the price of carnations is actually going to go up and the quantity of carnations will go up because the demand for carnation will go up. Now, a lot of people were confused and saying, well, but how come if roses and carnations substitute, how come when the demand for roses increases, how come the people buy more carnations? Well, if we don't necessarily assume that the people buying roses are people who were buying carnations before, but simply that there are people who want more flowers, then it makes sense. I mean, think about what happens in Valentine's Day. A lot more people go to the flower store, so that a lot more people want flowers altogether. So a lot of people will go to a flower store. Some of them will not be able to afford the roses, so they will go for the carnations. So the carnations, actually, the demand for carnations, even in Valentine's Day, goes up, and the price of carnations, even in Valentine's Day, actually goes up. So the price of carnations goes up, the quantity of carnation goes up as a result of the first event. The second event actually increases the cost of producing flowers. That's going to increase the price of carnations because the supply curve is going to decrease, and that's going to reduce the quantity. Now we analyze two things separately. Now let's see what's the combination of the two. The price is definitely going to go up, but the quantity we don't know. The demand change increased quantity, but the supply change decreased quantity. We don't really know which of the two changes was actually more. The question doesn't tell us that. We won't be able to tell what happens to quantity. So therefore, the result of this question will be that the price goes up, but the quantity change is ambiguous, or we can't really tell. It's undetermined. We can do the same thing with the graph. This is a situation in which the supply curve goes to the right. I mean, the demand curve goes to the right because there's actually more demand for carnations, and the supply curve goes to the left because it's more expensive to produce flowers. The result of that is that the price goes up and the quantity goes up. But we could have done the same thing, or the question could have also been answered by shifting the supply curve by a lot, say by this much. And if that was the case, the quantity would have actually ended up being less and not more. Since the two possibilities are possible given the question, we won't be able to answer what happens to quantity, only what happens to price. You can answer this with a graph or without a graph. As long as you keep your work organized and you do one thing at a time, then you should be fine. I hope you have a good time in the exam. Happy studying, and I'll see you tomorrow.